where you see the passing of time,
The crowds in St. Peter's Square are praying like mad for the Pope's life.
where moments refuse to die,
This is a momentous hour in world history. This is the invasion of Hitler's Europe.
and where victory lives on.
Plenty of girls are being kissed by plenty of boys they don't know, and they do not care.
You can love it, hate it, embrace it, or turn away.
Lennon was shot to death late last night outside his apartment building.
But it is a past we all share.
Come on out here and give me a salute. Big Navy salute.
This is where yesterday has a home, where we wonder what it was like back then
Go forward, knights, in safety.
and not too long ago.
His spirit must live on.
It's where history has its place and where the past comes alive. The History Channel.
Few industries are as big, or as old, or as crucial to human survival. From the dawn of civilization to the future of a small planet. Now, plumbing, the arteries of civilization on Modern Marvels. If there is one fact of human life we all hold in common, it is our dependence on water. Regardless of race, creed, social strata, or historical era, we all rely on it for our very survival. Through all of its uses in modern daily life, the average American consumes more than 50 gallons of water per day. To reach the fixtures that place it at our fingertips, the water is often transported hundreds of miles from its source in the earth. Once it's reached the city, thousands of miles of underground water main carry the water into buildings, where it flows hot and cold at our beck and call. The art and science of plumbing is based on a fundamental law of nature. Water flows downhill. Like nature's rivers, man-made aqueducts are built on a downhill slope, using gravity to propel the water. The pressure in plumbing pipes is also created by gravity. Water is pumped to the top of giant towers which are connected to the mains beneath the streets. As long as the tower is higher than the water's final destination, gravity will maintain pressure and force the water through the pipes. In buildings that are taller than the water tower, water is pumped to a series of pressure tanks in the building, each one using gravity to feed the floors below it. After water is used, gravity once again carries it away. Sewage treatment plants are built at the lowest possible elevation, and sewer pipes are built at an angle so that wastewater can flow downhill. After the sewage has been treated, it flows by gravity into the nearest waterway, where it is reclaimed by the earth. We've come to expect everything of modern plumbing, and rarely do we give it a second thought. But just how crucial it is to our daily lives is made painfully evident by the predicament of developing countries who struggle to survive without its benefits. Indeed, if our plumbing systems were to fail us, our cities and towns would collapse like helpless giants.
Plumbing is such a basic, essential need, delivering of fresh, clean, potable water, water that can be used, and then, more importantly, after it's used, disposed of properly. Because that sewage, if it's not properly treated, is a tremendous cause of disease. And yet our standards of living, our standards of safety and sanitation keep that from becoming a reality in our world today.
Today, the plumbing industry is one of the largest in the world in terms of business volume. Surprisingly, most of America didn't have what we would consider basic indoor plumbing until as recently as the turn of the century, but its principles can be traced back thousands of years. Mesopotamia is what is today Iraq. It was here, on the once fertile plain between the Tigris and Euphrates rivers, that Western civilization was born more than 50 centuries ago. From the earliest days of modern archaeology, the mysteries of our origins have slowly been unveiled. In the ruins of ancient cities, archaeologists have found unmistakable evidence that supports a fundamental theory that the civilization of mankind is inexorably linked to our ability to control the flow of water.
Plumbing is civilization. Just about every civilization that we look back on in antiquity, that we study and admire for their contributions to art and literature and science, technology, civil order, also were highly developed plumbers.
Fresh water could be carried by hand, but disposing of waste and excess rainwater in early cities required ingenuity, and the earliest civilizations rose to the occasion. Intricate drains were built beneath floors to carry away water. The remains of bathrooms and cesspits, similar to modern septic tanks, have been found not only in Mesopotamia, but 1,500 miles away in the Indus Valley in what is now Pakistan and Western India. Here, buildings dating back to 2600 BC had private wells and bathing areas with drains in the floor.
The ancient people were as smart as we are. They were very intelligent, they were very inventive. And they came up with some remarkable solutions which we're still using. They figured out how water runs, and they figured out most effectively and most efficiently how it runs.
By the 6th century BC, the city of Babylon had expanded into a thriving metropolis. For centuries, it had been a center of learning and culture. But under King Nebuchadnezzar II, Babylon grew to become the most magnificent city in the ancient world. The king's bath was most likely a shower poured over him by slaves. The palace had separate bathrooms with elaborate drains connected to a covered sewer system. Latrines with raised seats also emptied into the sewer, which sloped downward to carry the wastewater away. But the palace's most famous feature were its hanging gardens, an engineering feat so remarkable that the Greeks named it one of the 7 wonders of the world. To irrigate the trees planted atop the 7-meter-high wall, historians believe the Babylonians used a mechanical device called a shadoof. A shadoof used a fulcrum and wooden beam with a bucket on the end to raise water from rivers to elevated troughs.
I suspect that this is the way that this was done. If you have a whole series of those, 3 or 4 of those, you can actually lift water quite high.
By 2000 BC, fresh water was flowing through various forms of pipe. In China, bamboo reeds were hollowed at the joints and used to pipe not only water but natural gas to and from the ancient salt mines. On the island of Crete, the Minoan kings had bathrooms with hot and cold running water as early as 1500 BC. In King Minos's palace at Broad Knossos, archaeologists have found a large ceramic bathtub, along with the world's first flushing toilet. The earliest plumbing pipe was made of baked clay and straw, but the ancient Egyptians, with their advanced metallurgy skills, were among the first to make pipe out of copper. The Egyptians' plumbing prowess was consistent with their expertise as builders. Wells were dug as deep as 300 feet, and the noria, or water wheel, was born in Egypt.
Interesting sidelight about the Egyptians is that they may have been the first and perhaps only civilization ever to build bathrooms for the dead. Their pyramids were kind of temporary resting places for the deceased to pass to the afterlife, and some of the pyramids that have been excavated, it turns out, also had bathrooms in them.
The Greeks advanced the art and science of plumbing to an unprecedented level. Hot and cold running water and bathtubs were all part of daily life in ancient Greece. Giant aqueducts carried water into the cities, and glorious fountains displayed it. But magnificent as they were, the accomplishments of all these civilizations would soon be eclipsed by the greatest society of plumbers in history, the Romans. The California Aqueduct. Built in the 1970s, this man-made river is the largest in a system of aqueducts that supply the Los Angeles area with water from the north, and at 444 miles, it is the longest one in the world. More than 1,000 years ago, another great city thrived on water brought in by these marvels of engineering. The magnificent structures that survive to this day have become icons for the brilliance of the Roman Empire, and not surprisingly. They carried millions of gallons of water from the mountains 50 miles away, a feat no civilization had ever attempted before. Once it reached the city, water was distributed through a grid of supply lines under the streets. What made it all possible was a material that was to give plumbing its name, lead. The Latin plumbus means lead, and the first Roman plumbers were artisans who fashioned sheet lead into everything from basket frames to the miles of lead pipe that supplied water to the hundreds of fountains, public buildings, and private homes throughout the empire. But perhaps most importantly, this running water was the lifeblood of one of Rome's most treasured institutions, the baths.
I think the most interesting thing about Roman baths is, in fact, they were a kind of Disneyland for the average Roman. And that was true because of the extraordinary abundance of water in all of these various bath rooms and bathing chambers, but also because they were very elaborately decorated. A scholar who recently wrote about the baths of Caracalla has said that this was a means for giving the common people the chance to live the lives of the rich and famous. The emperors themselves used these baths as a means of giving the people a kind of wonderful entertainment facility, which would prevent them from thinking of other things like political freedom, for example.
Beneath the splendor of the baths was a marvel of engineering. Millions of gallons of water flowed in and out of the complexes, heated by wood and coal-fired furnaces to precise temperatures, providing an array of choices for the bather. There were separate steam rooms and radiant heating throughout, accomplished by pumping hot air through channels beneath the floors. Wastewater drained out of the buildings and into large sewer pipes that emptied into the Tiber River. The largest of these sewers, the Cloaca Maxima, predated the first aqueduct by a half-century and is still used today as a storm drain. In fact, its original purpose was just that.
The sewer system that ran under Rome was basically to take away the rainwater. It was only an afterthought that people thought, well, as long as that water's going by, we might as well throw our stuff into it. And so they did their business into the system.
And doing their business was often a social event. Public latrines had as many as 20 seats arranged in a circle. Water ran constantly beneath the seats, washing the waste into the nearest sewer. When the Roman legions set out to conquer the world, they brought their plumbing with them. The baths of Aquae Sulis were built by the Emperor Claudius in the 1st century AD on the site of a natural hot springs. They were restored in the 16th century, and today they're a popular tourist attraction in what is now the English town of Bath. Water still flows through the original stone channels into the 80 by 40 foot Great Bath, a kind of scaled-down version of the ones back home in Rome. And after nearly 2,000 years, they're a testament to the durability of Roman engineering. As it turns out, the empire itself was not so durable. When it finally fell, so too did the state-of-the-art of plumbing.
For one thing, Rome was conquered not by a new civilization that surpassed it, but by a bunch of barbarian hordes who were basically nomads and plunderers. And they didn't really give two hoots about running water. They were never in one place long enough to enjoy indoor plumbing. Christianity started spreading throughout the Western world, and the early Christians were not big fans of bathing, and I think one of the reasons is that, as I think everybody knows, they were rather poorly treated by the Romans, and thus they tended to reject Roman culture, and I think they threw out the proverbial baby with the bathwater.
With people crowded into cities during the Middle Ages, the unsanitary conditions brought consequences that were nothing less than deadly. Throughout what has been aptly named the Dark Ages, entire populations suffered some of the worst health consequences in history. Thousands upon thousands lost their lives to waterborne diseases. the nature of which wouldn't be understood for centuries to come. Typhoid, typhus, cholera, dysentery. The resulting conditions spawned the infamous Black Plague, which was spread by rats and insects and killed an estimated 1/3 of Europe's population. Unaware that they were being poisoned by their own filth, people attributed their terrible misfortune to the wrath of God. The traces of plumbing and sanitary practices that did exist during the Middle Ages were in monasteries and in the castles of feudal lords, where garderobes served as indoor privies.
The garderobe was a projection from a building, which inside contained a seat on which you sat and simply went straight down into the moat or the river or the ground below. And there are several surviving ones in England. And miserable menials would come and scrape away the dirt in the morning in grand establishments.
So the invaders, if your castle was under siege, everybody would go a lot, and you'd see this, and the one thing you didn't want to do was go through that moat.
With the Renaissance came a renewed interest in hygiene, and so began the steady march toward indoor plumbing. The first step was to bring water into the home by hand.
Almost every home throughout the land had a washstand in the bedroom, which, if they were lucky enough, a maid would bring up with a jug of hot water and a jug of cold water, and then there'd be the bowls. And they'd always be there in matching china, and ravishingly beautiful examples still survive to this day of these wash hand stand sets.
Chamber pots of every description made up in form what they lacked in function. And emptying them was simple enough. Open the window and toss the contents onto the street. This practice gave rise to the popular nickname given the modern toilet in Britain. The proper etiquette for emptying one's chamber pot was to warn passers-by with the French phrase "gardez l'eau," meaning look out for the water. This was anglicized to become gardez-l'eau, hence the time-honored term loo. For the origin of the popular nickname John, historians look to none other than the Queen of England.
Queen Elizabeth I had a bath once a month, whether she needed it or no. John Harington was her godson, and he invented apparatus, a machine, a water closet with proper flushing mechanism in 1596. And the Queen also had one made for her, but she was too frightened to use it. She said it sounded like a thunderstorm, and with these terrifying rushes of water.
Ridiculed by his peers, Harington produced only 2 of the toilets. 170 years would pass before his invention would resurface. What could be more simple than a tub for bathing? Before indoor plumbing, bathtubs were simply filled and emptied by hand. It was from this elementary idea that modern baths and showers evolved, but not without some colorful experiments along the way. The concept of the shower began in ancient times with waterfalls and buckets of water, but by the mid-19th century, some intriguing designs were in the works. One of the earliest was the English Regency shower, which pumped the same water continually from the drain to a cistern over the bather's head. The American Virginia stool shower was a seated affair with a hand-operated pump and backbrush. There were numerous variations, including this self-pumping shower, which combined a cleanup with a vigorous workout. What few may realize is that the newfangled showers of today are nothing new. Their predecessors date back to the mid-1800s.
And one I found on the Isle of Rum had this great canopy over it with 12 different versions of water acrobatics that you could indulge in. There was one called Spray, which had 280 tiny needles of water that jetted at your whole body all the way around when you stood in. And then there was the ordinary shower. And then there was Douche, which was like an apple corer going straight through your head, a solid great ramrod of water. And then there was another really scary one, which was a ramrod up your privates. I mean, really, really scary and strong. And then there was a Sitz, which was a fountain for the same delicate area. And then there was Wave, which when you turned it on, it shot out 20 foot horizontally across the room, the water.
Later generations of the shower would be much simpler, But another device evolved during the 19th century, one that few had seen before. John Harrington's invention would be emulated by a new generation of innovators and transformed into a household word. With the first European settlers in New England came the seeds of what was to become the most advanced plumbing industry in the world. But it would take several centuries to get there.
Cleanliness was not a treasured value of colonial America by and large. People rarely bathed. They rarely took baths. They might do so once a month, a couple of times a year.
Nonetheless, as cities were built, running water was a high priority, not for bathing, but for firefighting. The first water system in America was built in Boston in the mid-1600s. By 1795, to supply firefighters with water, hollow logs were joined together to create a water main stretching 4 miles from Jamaica Pond to Faneuil Hall. The firemen would simply drill through the walls of these primitive pipes and plug the hole when they finished. This is the origin of the term fire plug. By the early 1700s, New York City had its own system of wooden mains, but they were hardly adequate to supply the growing city with water. In 1835, New York built its first reservoir in Midtown Manhattan, fed by aqueduct from the nearby Croton River. The reservoir filled several city blocks and lasted until the turn of the century, when 2 underground water tunnels that supply New York to this day were built. Construction on a 3rd tunnel was begun in 1970, and the first channel just recently went into service. When City Water Tunnel number 3 is completed in the year 2020, it will stretch 60 miles and convey 1 billion gallons of water per day. During the early years in America, the great outdoors proved an appealing alternative to the chamber pots from the old country. But before long, Yankee ingenuity gave birth to an American institution, the outhouse.
Outhouses were basically the bathrooms of the early colonial settlers in this country, and some of them were quite ornate.
The technology was simple enough: a deep hole in the earth, a seat, and a wooden shed with a door. Outhouses continued to proliferate through the 19th century in America, well beyond the advent of the indoor toilet. With independence came innovation. Thomas Jefferson devised his own waterless indoor privy at Monticello, a chamber pot connected to the outdoors by a series of pulleys operated by servants. Meanwhile, a new generation of inventors in England had revived John Harrington's bizarre invention, and updated versions of the water closet flooded the British patent offices. American innovators weren't far behind, but the general public was slow to accept such a radical idea.
The early water closets were kind of Rube Goldberg contraptions. They were made of metal. They were made with various different parts. These parts did not always fit together well. They left gaps. People enclosed them in wooden cases to make them look like furniture, and waste used to collect in these gaps and ledges and things. So it was very unsanitary, and after a while smelled pretty bad, and they didn't work very well.
Compounding the problem was the seemingly insurmountable nuisance of sewer gases leaking into homes. The trap seal had already been invented and was in theory a brilliant solution. A U-shaped section of pipe beneath drains and toilet bowls uses a simple law of physics to create a water seal blocking sewer gases from entering the home. But another law of physics had been overlooked, the principle of venting.
What the vent does is allow air to come into the drainage system, so when that water falls, the air goes with it, and it doesn't suck the water out of that trap. Very, very simple. If the vent isn't there, it would be like a gallon jug. When you turn it over, remember that glug, glug, glug that used to happen? That's what your drains would work like. Not very well.
Today, venting is a rudimentary part of every plumber's training, but few know how it all began.
There is a record in 1874, a plumber whose name is lost to the ages, unless somebody can recover it somewhere along the way, who left a diagram for a house that had been having severe problems with odor inside the house that was duplicated for other homes, and this kind of began the era of what we really can consider to be modern plumbing.
Meanwhile, across the Atlantic, the water closet continued to evolve. With improved designs and the increasing availability of running water, the indoor toilet had finally caught on. But perhaps the most controversial figure in the history of the WC is the most well-known. His name was Thomas Crapper. When this biography of Crapper was published in 1969, many believed it was a hoax. What followed was a string of independent investigations and a heated debate within the industry. Did Crapper actually invent the forerunner of the modern toilet? Did the man actually exist? Even today, those who are privy to Crapper's story continue the debate.
He was born in Thorne in Yorkshire, and at the age of 11, he worked as a plumber. And he got fascinated by the toilets. And originally, the thing that Crapper developed was called the water waste preventer. If you lift the lid of your loo now, it's exactly the same as when he developed it 100 years ago.
Frederick Humpherson was my great-uncle, and he was apprenticed to Thomas Crapper in 1871, and these are his apprenticeship papers. And here's the signatures. Thomas Crapper did not invent a WC pan, he did not invent a WC cistern. Indeed, he did not even invent the siphon for which so much fuss is made.
James Watt didn't invent the steam engine, he just made it work. Marconi didn't invent wireless, he just made it practical. It's the same with Crapper. A lot of people were working on it at the time, and he made one that worked.
Americans cannot get over the fact that there was a man selling plumbing fittings with a name like Crapper. Now that's amusing, and it's great, and it's fun. But that he invented the loo, and he had anything to do with inventing the loo, is, I'm afraid, a myth. The WC pan, which is universally recognized today, was designed by Frederick Humpherson in 1884. That's my great-uncle, Frederick Humpherson, and this is the famous WC pan, the Beaufort, the first pedestal washdown closet.
The earliest WCs were encased in wood cabinets, hiding all but the inside of the bowl. But once they came out of hiding, the era of the designer toilet began.
Little pedestal was decorated in every conceivable fantastical form. I mean, an array of such glories, from the wildest gilding to the wildest shapes. Quite wonderful. Two reasons I'd suggest. One was because of the love of decoration, and the other was to hide the exceedingly immodest object that they were dealing with. But I discovered a white swan in the assize courts in Durham, where the judges would have had to swing their legs over the back because the swan's neck came up, so they couldn't stand in front of it. So they would have had to, robes and all, swing their legs over and sit on this swan.
With the proliferation of water closets came an unprecedented abundance of sewage. The cities of Europe were the first to pay the unseemly consequences.
London, for example, was choked stiff with filth. It had 3 veins, shall we say, 3 rivers flowing through it, the Fleet, the Thames and the Walbrook stream, and they were all choked stiff with the excrement of the hundreds of privies that dropped into it. And it became so bad that the streets too were filled with excrement, and people were fined if they allowed their privy to overflow. It was horrible. Reeking, stinking, reeking, stinking.
But in 1858, London's newly formed Metropolitan Board of Works undertook an historic project under the direction of Sir Joseph Bazalgette, the construction of London's first sewer system.
Beautiful brick vaulted sewers, like the undercroft of a cathedral. Under London, throughout, there's a great huge network of this beautiful Gothic vaulting, which Sir Joseph Bazalgette built, and thereby saved the population of London, and indeed the world, by setting such a good example in the 19th century.
A world away in Chicago, America's first integrated sewer system was built in 1856, but the young city was facing a contamination problem that sewers alone couldn't solve. Increasing quantities of raw sewage were dumped into the Chicago River, which emptied into Lake Michigan, the city's only source of drinking water.
As more and more people started coming into the city, they had to take those water intakes and move them further and further into the lake. And for a while, it worked. But then in 1885, there was a tremendous 4-day rainstorm that just flushed all these primitive sewers way out into the lake so that the water intake cribs were inundated with this polluted material. 25% of the entire population of the city of Chicago perished from waterborne diseases during that time: cholera, typhoid, etc., dysentery. Something like 75,000 deaths.
The Chicago River was the only viable conduit to carry away the enormous daily flow of sewage from the growing city. Chicago now faced a nearly insurmountable problem.
Here were these thousands and thousands of people coming to live in the city. They could not live under those conditions where their water supply was polluted, so that a massive, imaginative, dynamic solution had to be found.
The answer was a mind-boggling feat of civil engineering. A 28-mile canal was dug connecting the Chicago to the Des Plaines River, a tributary of the Mississippi, thereby reversing the direction of the river.
This canal was dug through solid rock. It was built with the might and the muscle of 8,500 laborers, most of them newly arrived immigrants from Europe, working with steam shovels and pickaxes and whatever they could. It took a great deal of imagination and daring to attempt a feat like this, to actually reverse the flow of a river.
The project was a resounding success, but it wasn't to be the last civil engineering milestone for the city of Chicago. Within a few decades, there would be another. At the turn of the century, a second industrial revolution was well underway in America. The late 1800s had seen the development of electricity, the telegraph and telephone, and the steel, chemical, and petroleum industries. America, along with Germany, had become a world leader in industry, with larger factories powered by electricity and multinational companies exporting new technologies around the world. In 1913, Henry Ford created the first assembly line for making Model Ts, and mass production was born. By now, plumbing in America had caught up with the rest of the world, and the industry flourished. Bathrooms were designed into new homes as a standard feature, along with hot water heaters and fully plumbed kitchens. Bathtubs and fixtures could hardly roll off assembly lines fast enough to satisfy the demand.
As bathrooms started getting built and bathtubs moved indoors, the tradition of the Saturday night bath kind of arose around that period, and we entered an era in which taking a bath once a week was considered the civilized thing to do. But taking a bath any more than that was considered a waste of time and probably rather excessive. Why would you do it more than once a week? You were already clean. Starting around 1920, an old industry magazine started publishing a campaign for a bath a day in American society, and they distributed a lot of pamphlets. Some of our records show over 100,000 pamphlets were distributed to schools and to plumbing customers throughout the United States, urging them to take a bath a day.
Plumbing pioneer John Michael Kohler created his first bathtub from an iron horse trough in 1883. Then in 1911, the Kohler Company made the first one-piece bathtub with an apron, which was soon to become the standard bathtub design. New toilets and wash basins were made of vitreous china with brass fixtures, and color-coordinated sinks, tubs, and toilets were introduced. In the 25 years between 1929 and 1954, manufacturing numbers skyrocketed with a 367% increase in plumbing product sales. The era of the professional plumber had arrived. Louis Pasteur's germ theory wasn't widely accepted until 1890, but now the nature of waterborne disease was well understood. Finally, the world could see just how high the stakes of sanitary plumbing were. Professional associations were formed and formal apprenticeship programs were put in place. By the mid-30s, uniform plumbing codes were legislated, and manufacturers established standards for plumbing products. Chicago, 1930. The sanitary ship canal had successfully reversed the flow of the Chicago River away from Lake Michigan and was hailed internationally as one of the 7 wonders of American engineering. But with the population continuing to grow, the city's problems were far from over.
At that time, through the canal that they had built in the North Shore Channel, the city was taking 12,000 cubic feet of water per second out of Lake Michigan to flush the system clean. But even with that large amount of water, it was still more or less a large open sewer, particularly whenever it rained. We would have a fresh influx of pollution into the river itself.
To address the problem, the Chicago Sanitary District created the largest and most advanced sewage treatment plant ever built. The facility, built on a 570-acre plot in nearby Stickney, was decidedly ahead of its time. When the EPA set strict new standards for sewage treatment more than 30 years later, the Stickney plant already exceeded them. By 1939, the Stickney plant was processing 1.2 billion gallons per day of wastewater, making it the largest facility of its kind in the world. But even that couldn't solve a problem that continued to plague the Chicago Sanitary District. Like all older cities, Chicago uses a combined sewer system for both sanitary waste and rainwater collected in storm drains. The problem? Intense rainstorms. On the average, the Windy City has 100 of them a year.
Once you get more than a little bit of rain, it was necessary to divert this mixture of sewage and rainwater away from the sewer pipe because it would flood out the sewage treatment plant. And so at various points along the Chicago River and other waterways, the canals, there would be overflow points. And so the mixture of polluted material, rainwater and sewage, would then go into that waterway.
At times, the overflow would back up into the basements of thousands of homes, and scores of highway underpasses would be flooded, grinding traffic to a halt. Once again, Chicago met the challenge with a bold and ingenious solution. Using the latest tunnel boring technology, engineers dug a series of tunnels through the thick dolomite rock, between 150 and 300 feet below the city, to literally bottle the rainstorms.
The drop shaft would go down to where the tunnel is, in some cases dropping down 300 feet. The tunnels themselves are as large as 35 feet in diameter and can contain up to 1 billion gallons of combined sewage mixture.
The water is stored in the tunnels and in reservoirs until the storm is over. Then it's pumped back to the surface and into the sewage treatment plant. World War II had a powerful impact on the plumbing industry. By 1940, the War Production Board had severely restricted the use of iron, steel, and copper, and manufacturers had to experiment with new materials such as cast iron and plastics. The innovation started a new wave of improved plumbing products that has continued ever since. It was as recently as the 1940s that Al Moen invented a faucet most of us take for granted.
Al Moen figured out a way to do it with just one handle, and by manipulating this handle, achieved the right mixture of hot and cold water, and now single-handed faucets are among the most popular around.
Modern hot water heaters are all equipped with an essential device invented in the 30s by the Watts Regulator Company, who still manufactures them today. It's known in the trade as a T&P valve.
without a temperature and pressure relief valve. The pressures inside of a water heater can build up to the extent that your water heater may someday take off, and if you live in a 3-story house, it could conceivably go through the first floor and the second floor and the third floor and the roof and end up in a neighbor's house maybe a quarter-mile away. These things used to happen quite commonly in America. They still happen once in a while in homes where the water heater does not have a T&P valve. But this was a great invention, and I'm sure has saved untold lives in America, and most people don't even know they have them.
And what will they think of next? Computerized toilets and remote control whirlpools are only the beginning. Cutting-edge science is doing things with wastewater that even the Romans could never have dreamed possible. The basics of safe sanitary plumbing are no longer a challenge for the modern world, but do the innovations continue? In a word, yes.
The bathroom market has exploded with new materials of all kinds, new designs, new shapes from a multitude of manufacturers.
This new toilet from Japan has a computer in it to control the flow of water. It also has a heated seat, a built-in fan to remove odors, and a remote-controlled washlet, which adds the function of a bidet to the unit. High-tech bathrooms, computerized temperature controls, multifunction self-cleaning shower heads, and waterproof wireless remotes for whirlpools that control everything from lighting to the flow of the jets. But beyond the high-tech features, there is a theme to the new wave of plumbing products, and it's consistent with the latest preoccupation of municipalities around the world: water conservation.
Somebody such as myself who may be discussing plumbing history 25, 30, 40, 50 years from now may look back and define one of the watersheds of plumbing history as the 1992 Plumbing Products Efficiency Act, which involved the federal government mandating that no toilet will flush with more than 1.6 gallons of water. The previous standard was 3.5 gallons. They also put restrictions on flows of faucets and shower heads as well. I think it's the first step of what is going to be a continuing trend towards making plumbing products more environmentally friendly.
The future is going to be required that we become custodians of water. We deliver to you fresh, potable, safe water in basically unlimited quantities. And then we take that waste and we send it away. Our challenge is going to be to come to you and to continue doing what we've been doing for the last 10 years, which is slowly reducing the level of water consumption, because it's going to be a battle that we're all facing.
Santee, California. This community of 54,000 was built in a desert valley just east of San Diego. There's virtually no rainfall here, and Santee is at the end of the pipeline that supplies water to Southern California. But despite the short supply of fresh water and droughts, this town is teeming with lush greenery and not one but 7 recreational lakes. It's a phenomenon that would have been impossible 100 years ago. The secret? Recycled water. At this state-of-the-art treatment facility, wastewater from Santee's sewers is converted to crystal clear water, so clean that it meets laboratory standards for drinking water. Once the chemically activated sludge has been removed, the water is filtered and put through an advanced process of biological and chemical treatment. 1 million gallons of reclaimed wastewater are fed to the lakes each day. Another 1 million gallons are used to irrigate the community. The water is distributed throughout Santee through an underground pipeline system that's carefully labeled and color-coded in purple, the standard color to indicate reclaimed water. During the 3 decades since Santee launched its breakthrough experiment, dozens of other communities around the country have implemented their own reclaimed water programs.
They can treat any kind of water. The dirtier it is, the more it costs, but you can treat it. And then they've also established processing treatments for water treatment, so that literally you could take this sewage water very shortly and use it for drinking water.
Shocking as it sounds, experiments are currently underway for that very process. The deliberate and safe introduction of recycled wastewater into potable water supplies. The importance of keeping wastewater as far as possible from drinking water is one of plumbing history's most important and expensive lessons. Now, modern technology has brought us full circle. If mankind has walked the earth for roughly 2 million years, it's only during the last 10,000th of that time that we've had what we consider basic modern plumbing. And yet, living without it is all but unfathomable. Mundane as it may seem, plumbing is our past. It is our future. It is the arteries of our civilization.